Yes, before you add or subtract fractions, you need a common denominator. So in our little example up top, 2/3 plus 5/6, how do we go about getting a common denominator? Yes, you multiply 2/3 by what over what? What will make 3 the same as 6? 2 over 2. That's what we're multiplying by. What you're actually doing without consciously knowing it is you're finding what is called a least common multiple. That is the smallest number that both numbers can multiply to be. So our least common multiple is 6 in this case. 2 times 2 gives us 4. 2 times 3 gives us 6. So now that we have common denominators, yes, Liz? Least common multiple, the definition is, what is the smallest number that two numbers can multiply to be? So if I have 3 and 6, the least common multiple is 6. They can both multiply to be 6. So now that I have 4/6 plus 5/6, what do I do to combine these? Yes, you keep the denominator and add, whoops, where did we go? Okay, you keep the denominator and you add the numerators. So what is 4 plus 5? 9 over 6. Is that our final answer? We need to simplify it. How does 9 over 6 reduce? What goes into both 9 and 6? 3. What's 9 divided by 3? What's 6 divided by 3? So we have 3/2. So notice, let's talk about the process here. What did we do? Found the least common multiple and used that to get what? Common denominators. Then what did we do? We added the numerators, and then what did we do? We reduced. Oh, we kept the denominator, you're right. We kept the denominator, and then we reduced. We canceled. We canceled. Same exact process when we are trying to do adding and subtracting rationals. So this is the easiest one, example number 1. What do you notice about these two? The denominator is the same. So what can we immediately do? We can immediately subtract. Now when we subtract here, we have to combine like terms. What are our like terms in the numerator? 7x and 3x and 4 and -4. But we need to make sure that we know we are subtracting both of these like terms. So what is 7x minus 3x? 4x. And what is 4 minus -4? 0. No. I just repeated. What's 4 minus -4? Ah, the minus negative makes that an addition problem now. So 4 plus 4 is actually 8. So we have 4x plus 8 over x squared plus 3x plus 2. What do you think we need to do to make sure that this is our final answer? Remember, what was the last step? After we combined up here, what was the last step we did? We simplified by canceling out actually what is a factor. The factor we canceled out was 3. So here, in order to know if things cancel or not, what am I going to have to do? Can I just do this? Oh yeah, that's a 4. Yeah, cancel those x's. Yeah, that looks good. Is that how canceling works? Why can I not cancel like that? Because you have addition between your terms. We can only cancel when what? On our warm-up. Why could we cancel here? What's between all of these? Multiplication. When there's multiplication between your terms, whoa. Ugh. When there's multiplication between your terms, that's when you can cancel. So, again, how do I figure out if stuff can cancel? What do I have to do? Factor. Yes, factor both. So, what do I do to factor the numerator? You can pull out a 4. So we have 4x plus 8. We're pulling out a 4, dividing out a 4. What are we left with? X plus 2 over, we need to factor this denominator. How do we do it? We're trying to get our 2 binomials here. This is a quadratic. How do we factor it? A times, yes, that A times C thing. What is A times C? 2. And what's our B? What multiplies to be 2 but adds to be 3? 2 and 1. So how do I write those factors? Eli, how do I write those factors? Good. What can happen here, Richard? Oh, I'm pulling the people that already talked. Yes. You can cancel out the x plus 2's. What are you left with, 8 and D? Yes, just a 4 in the numerator over x plus 1, and you're done. So, again, the steps here. Make sure you have a common denominator. Add the numerator, factor everything, and simplify. Any questions on this one? Okay. Now, I know that in your heads, you're probably thinking, oh, this looks easier. Is this problem easier? Why or why not? Yes. It's actually not easier because you aren't immediately given a common denominator. So, what is the smallest thing both of these can multiply to be? Or in other words, what does this have that this is missing? An x. So, what you're going to do is you're going to multiply this fraction, this rational, by x over x. Why are we multiplying by x over x and not just multiplying the denominator by x? Right. Because if we just multiply the denominator by x, you would be changing the value of this fraction. So we need to multiply by something that's equivalent to 1. X over x reduces to 1. I am abiding by math rules. I'm good. So now we have 5x over 8x. Now what do you think I do? You subtract the numerators and keep the denominator as 8x. What is 5x minus 3? They are unlike terms. You cannot add or subtract unlike terms. So it remains 5x minus 3. Can this reduce? No. Nothing factors here. In 5x minus 3, you can't pull out a GCF. You also cannot cancel the x's because there's a subtraction between 5x and 3, so you can't cancel. This is our final answer. 5x minus 3 over 8x. So I guess in the end, it was an easier problem. Any questions here on this one? I know unfortunately, there's a lot of examples before I can let you do this because there's different types of adding and subtracting. Already, we've gone over 2 types. Number 1, the denominators were already the same. Number 2, they're different. Number 3, we're going to need to change both denominators. What is the smallest thing that both of these can multiply to be? We have 4 over 9 plus 1 over 3x in example 3. It'd be what? So it'd be hard to get 9 to be 3x. Yes. These can both multiply to be 9x. That's what is called our least common multiple, is 9x. So, what am I going to multiply 4 9ths by to get the denominator to be 9x? X over x. And what am I going to multiply 3x by to get that to be 9x? So I multiply by 3 over 3. So I multiply the numerators. 4 times x is 4x, and multiply the denominator. 9 times x is 9x. Do the same thing on the left-hand side. 1 times 3 is 3, and 3x times 3 is 9x. Now what? It's an addition problem, you're right. We take the numerator, and what is 4x plus 3? 4x plus 3 over, can anything reduce here? Can anything factor? Nope. That's our answer. So on example 4, what is the first thing we're supposed to do? Get a common denominator. Uh-oh. What's wrong with me immediately trying to get a common denominator? What do you think we have to do first, actually? You do have to factor that denominator first to figure out what factors you're missing on the other rational. So, how do we go about factoring x squared plus 7x plus 10? Yes, so a times c is how much? And b is what multiplies to be 10 but adds to be 7. As you guys get good at this, do you think you need to draw the x? It's an organizational tool for your brain. You just need to know you need to multiply to be this 10 and add to be 7. As long as you can figure that out, you don't need the x. So our factors here are x plus 5 and x plus 2. The 5x is still in the numerator. And then we still have a plus 4 over x plus 5. What is our least common multiple? Or, in other words, what does this have that this does not? An x plus 2. So what you can do is multiply the second fraction by x plus 2 over x plus 2 to force them to have the same denominator. So I'm going to rewrite my first fraction, 5x over x plus 5, x plus 2. Plus, this is now over x plus 5, x plus 2. What do you think if we're going to have to be combining like terms? What do you think we're going to have to do to this numerator? Can I, right now, add the numerators? No. What do you have to do? Yes, and how do we do that? Yes, distribute the 4 in. 4 times x is 4x, and 4 times 2 is 8. So right now we have 5x over x plus 5, x plus 2, plus 4x plus 8 over x plus 5, x plus 2. We now have common denominators, and we can identify the like terms in the numerator to add them together. What are my like terms in the numerator? 5x and 4x. Are there any other like terms? No. So those are the only two we need to combine. What is 5x plus 4x? 9x. And then we bring down the 8. So it's 9x plus 8 in our numerator over x plus 5, x plus 2. What do we now need to check for now that we have combined? Like factors that you could cancel. Can the numerator be factored any further? No, there is no GCF we can pull out. This is our final answer. We have 9x plus 8 over x plus 5, x plus 2. Are there any questions? Anything that you didn't understand? All right, you guys go ahead and do example 6.